We're going to look at systems of equations and inequalities. We're going to start off with a system of equations. Systems of equations are basically like two equations with two variables, or three equations with three variables, and so on. We're going to look at solving them with substitution and graphical solutions. Suppose we started out with this system of equations. Now, you guys have solved systems of equations before in your first three courses in high school. Now, here's our first system. Here's our one system, but our first equation, second equation. Since they both equal y, we could really set them equal to each other. So in other words, instead of writing this here, I can go ahead and take this, since it's equal to y. Sorry about that, and plug it in. So when we do that, we get this equation right here, which you'll realize is a quadratic equation, and to solve a quadratic equation, you want to go ahead and set it equal to 0 like we have over here. There's several ways to solve a quadratic equation. One of the ways is factoring. One of them is by the quadratic formula. If you did factor this one, it would be like this. You would then have two parentheses, or two things multiplied together to give you 0, so you set each one equal to 0, and then you get your two answers that are listed below. So in other words, this parabola here and this line cross at two different x values, and those are listed here, which means there's also points where they cross. Well, how do you figure out the y value if you know the x value? Well, if your x is -1, all you have to do is plug in -1 into one of your two equations. So if we plug it into the pink one over here, 2 times -1 plus 3, that's how we get the 1. So we have our line and our parabola crossing right here. We also have our x being 3 for the other one. Plug that in here, and we get 9. So the line and the parabola cross at this point also. So you can just use your substitution, and you can use your graph to support your answers to see if they are reasonable and right, is one way to do that. The substitution method is what we were just doing. For the most part, you just solve one of the equations for x or y. Most of the time it'll be solving it for y. And then you just plug it into the other equation and solve it. So as we take a look here, let's go ahead and take a look at the second equation. Since it's a y to the first, it's going to be easier to solve. So let's solve the second equation for y. Well, if we solve the second equation for y, we get a 19 minus an x squared. Then if we plug that in up here, we'd have a 19 minus x squared, and then we'd have to square the whole thing. Then we'd end up with an x to the fourth power. It may be easier to solve it not for our y, but for our x squared. If we solve it for x squared, we've got to subtract 9. Now the reason I'm saying x squared, because we also have an x squared right above it. So if we solve the second one for our x squared, we get this. Then all we're going to do is take that and plug it in up here at the top. When we do that, we ended up getting this, which once again is a quadratic. So you set it equal to 0, factor it, set each one of your factors equal to 0 and solve it, and so you get your two y values. So this circle and this parabola cross at two different points. One of them when your y is 3, one when the y is -2. Well, if you know y is 3, plug y in here, and you can find your y, or your x. If you know y is -2, plug it in here, and you can find your x. Well, it's no longer just 2 points, because you really get plus or minus 4 when you plug in 3. So you get a 4, 3, and a -4, 3. And then when you plug in your -2, you get root 21 and root 21. So it's really 4 different points this circle and parabola cross. And that's illustrated in the diagram over here to the right. Well, we'll continue to solve systems of equations. Once again, you can use substitution. But sometimes you can use what's called elimination. As we look at this system of equations here, you notice our y here and our y here have the same number in front. One's a positive, one's a negative. So all we're going to do is just basically add our equations together. We get 1x and 6x is 7x. Our y's drop out, giving us a 0. And then we add this over here, we get 14. We finish solving it for x, we get x to be 2. Well, if x is 2, we could plug 2 in up here and solve it for y. If we do that, that's what we're talking about right here. Solving it for y, we get y to be negative 1. So we then get our point to be x being 2, y being negative 1. So these two lines would cross at the point 2, negative 1, which when you look at your graph, the two lines do cross right there. Now, sometimes when you're solving system of equations, you can have more than just one point. Sometimes you can have infinitely many solutions. So here's our initial system of equations. But you notice the second equation here is really just double the first equation. So let's multiply the second equation by 1/2. You notice then both equations are identical. So when you look at your graph over here, your first equation is the blue one. Your second equation here is the red one. They're ending up being on top of each other. So they have infinitely many points in common. So there's infinite, if I can talk here, infinitely many solutions. Well, it is also possible that when we're dealing with a linear system, that we can have no points in common. This also happens with nonlinear systems, but most of the time it's going to be linear that will occur. Here, you'll notice your x is double that one, your y is double this one, but it's not double over here. Well, if we go ahead and solve this, we'll end up getting a 0 equaling an 8, meaning like a 0x plus a 0y equals 8. Well, it's obvious that 0 does not equal 8. So that's a false statement. False meaning they have nothing in common. They would be parallel lines. And you could see that up here, because if you solved it for y, you'd have the same slope, because your numbers in front of your variables are just double each other. But they would have different y-intercepts, and that would come from these numbers over here. So if two lines have the same slope but different y-intercepts, when you solve it for y, you end up getting parallel lines then. And parallel lines have nothing in common. So we have three possibilities going on here when you're dealing with lines. They could cross at one point, and that means it's a consistent system. They could have an infinitely many number of points in common. That's a dependent and consistent system. Or they could have no points in common, meaning the parallel lines. Then that would be considered an inconsistent system. So the first one is when you have two lines crossing. The second one is when you have two lines going on top of each other. The third one, you have parallel lines. So here's a summary of what's going on.